Hello everyone and welcome back to ATPeak Open Source AR Talk Series. Nova, our guest today, has quite an impressive resume for their young age. At only 11, they made their first presentation at the Southern California Linux Expo, focusing on how beginners can get started in the FOSS community. They want to make software that helps people feel comfortable and enables their creativity, a very noble cause. And around 2 years ago, they started to work on Stardust XR.
And today, Noah will talk about Stardust XR, what Stardust is capable of, the program that used to implement UI elements, and how to make your own system UIs with it. So Noah, let's begin.
Hello, everybody. I'm Nova. I've been doing open source for a while, and I really like to help because I'm a lot interested in XR. So let's start it off. Right. Okay. All right. So background XR design development, and it says intermediate and expert, but I'm going to try and make this super duper simple for everyone. So we'll start off with what is Stardust? It's an open source display server. And if you don't know, a display server is what lets applications talk to the system UI. In fact, you could classify the display server as the system UI in certain cases, which we'll get to later, right? So for example, the Windows taskbar is built on top of the display server, and all your mobile apps connect through a display server and so on. But unlike most display servers, this one is made in parts, right? Which I'll once again go into later. I've designed this specifically because I'm a designer and a developer, both specializing in XR design. That means that I have a really good understanding of what would users want to interact with, or how would they want to interact. My main conclusion is there's no one way. So Stardust is designed based on that. It runs on top of Linux because Android and so on did not have the correct architecture for very good user experience or developer experience. It uses modern open standards like OpenXR and Wayland. It uses StereoKit. I'll get into that later. The protocol is separate from the server. So when new technology comes along, people can re-implement the server, hopefully without much trouble, and get advantages to all the new features, maybe ray tracing or something like that. Who knows, right? That sort of ties into extensible. And I think it's the ultimate in accessibility. You can basically create any virtual objects for any disability, or you can even give people super abilities. Why not? So this is a more technical look into it, but don't get too intimidated, right? First of all is the legacy UI stack over to the right. This is how they used to do things back in the 90s. This example is X. You used to have two separate programs, an X server and a compositor, because every single desktop window actually had a fixed position in space, a fixed position in bounds, which meant that it assumed you had a 2D screen. So, I can't really use that in Stardust because it's fully XR, though. I would have to do a lot of shenanigans to get it to work. Like, for example, Wayland did, right? And by the way, KMS, kernel mode setting, that's how you get graphics to the screen. EVDev is how you get keyboard and mouse and so on to all of that stuff, right? And X clients you can interpret as apps. Okay. Then there's the modern UI stack. This is using something called Wayland. Again, it's somewhat important, but you don't have to know every detail. This one is how most modern operating systems do their graphics. You have one compositor, which has the entirety of the system UI baked into a block, right? And that allows for greater security and a whole bunch of different benefits. And once again, Wayland clients are apps, right? 2D apps. However, in Stardust, things have to be done a bit differently. For one, because we are in XR, we are in an unbounded 3D space. You cannot just have one team of designers and developers create a system UI, and that is the entirety of your experience with your XR device. It just doesn't work that way in terms of good UX. So instead, I've decided to make it to where the Stardust server does very little. All it really does is it sets up a few base elements that a system UI can be constructed with, like, for example, showing off models and accepting input in a particular bound, right? And then it lets the Stardust clients handle implementing the objects you interact with, right? So EVDev, once again, the inputs, keyboard and mouse, that would go through a Stardust client, for example. For convenience's sake, and because a lot of our drivers and setup isn't here yet, I decided to make Stardust work on top of an existing OpenXR runtime, like Monado. And that Monado would handle displaying to the displays, right? But you'll notice, though, that unlike Wayland and X that only support one type of client, Stardust will support Stardust clients, Wayland clients, and OpenXR clients, which takes me on to the different types of clients. There's a lot of stuff. I'm just going to skim through it, and if you want, you'll be able to get the slides. I'll publish them, right? So I'll do a contrast. For Stardust clients, they implement individual objects. So, for example, it could be something like a digital bracelet, right? Where you can take a Wayland client, which would be a 2D application or game, and put it into that digital bracelet in order to interact, right? A Stardust client would determine how your hand tracking and such is converted into a virtual touch event or so on. Could be any model, could be, any interface, right? OpenXR clients, however, are obviously for 3D and XR. Some people have tried to make XR inside of Wayland. It is totally doable, but I would advise against it specifically because OpenXR is a widely accepted standard, and also it works very well and it's optimized for XR compared to Wayland, which is not really optimized for that. Once again, OpenXR clients can be interacted with through a user interface that is made by a Stardust client. In this case, those user interfaces are called Orioles. So, Stardust clients are rendered by the Stardust server. This basically avoids a bunch of different compositing issues, and it also makes sure that they run super duper fast and stable and performantly, right? Wayland and OpenXR clients have their own toolkits and will basically render everything in them to send to your head through Stardust. Wayland clients use 2D things like GTK and Qt, and OpenXR clients use new things like StereoKit and Unity and Godot. Stardust clients work in a shared space. That's because they are system UI components. They should work together. However, with Wayland and OpenXR clients, they should be separate, though, because they implement a whole experience or application. There's a bunch of examples here, but I think I don't have much more time because I allocated 15 minutes, so I'm going to go ahead. Oop. That's time for demos now. So first of all, this is what Stardust looks like, though. Keep in mind, it's running inside of Monado, right? Monado is basically how you get OpenXR apps and open headsets to work inside of Linux. It's the best way, basically, right? I can't actually interact with the things because I'm using dummy driver, and I honestly haven't figured out how to use the controls yet, but it's a good indication of what it'll approximately look like through an XR device. This does work through XR already, which is really cool. It only uses hand tracking, though. I have the Workspaces client, which is the weird rings you see around, the Screen client, which is just a little demo to see what it looks like, right, and how you can point at a screen, and then I have a bunch of sliders. They're all functional, but they don't quite work in the talk, right? They don't work right now in this interface. So I'm actually gonna go and exit out of this, though. Yeah, it uses the terminal for now, but don't worry about that. Okay. So then, I'm going to show you some quick Stardust demos and how easy it is to start up. It's currently taking a while to start up because of a really cool special feature that I'm going to show off a bit later, but, I actually got faster. I went through the slides a bit faster than I expected, but that's fine. I said everything I needed to. So this is the base Stardust, though. This actually has the floor client running right now, in order to just display the floor model. And it also has a default sky text. It's like your desktop wallpaper equivalent, right? Obviously, the sky texture won't show in AR. Oh, and I want to add Stardust. Stardust sees all forms of XR basically identically. It doesn't see this is a VR device or this is an AR device. More, hey, we have a transparent screen that you can see through, and you also have the ability to see the room entirely, right? So it sees the little components, and that makes it a heck of a lot easier to create one interface that works in all of the different modes. So starting off with this though, let's go with a thing that I made specially for this event, which it's going to be useful elsewhere, which is workspaces. And I mean computer workspaces like this, right? Where you have a bunch of windows and objects in one space, and you have a bunch of other ones in another space, and you can flip between them. So let us launch it, right? This is not how applications are going to be launched, but for now is what's going on. So as you can see though, we're currently inside of a workspace, right? Once again, this is only one potential use for Stardust though, right? There are many others and many different interfaces you can create. As you can see, I have my simulated hand here, and if I grab it and I pull up and down to make a fist, it will then be able to move the workspaces up and down, just like how I can do this, right? But of course, this is not a lot. We should add some extra things in here. So the screen demo is not affected, but I think I actually haven't tested this out though, so it's a good live demo. Right here, see? So this is a environment item for the desktop wallpapers effectively. As you can see, I can grab it and move it around, right? And then I can also move it with the workspace, right? I can then move this outside of the workspace, and it'll work absolutely fine independently too. And I can also move it to where the workspace will be. I can pull this up, and now it moves with the workspace. So you can sort of imagine a ton of different possibilities for this, right? So let's show off the input system, right? Which is really, really unique. So because I have a bunch of different objects made by a bunch of different people, I have to figure out, how do I make sure that when the user tries to act on a particular object, it does what they expect it to do. So I came up with what I call the SUI, or Spatial Universal Interaction System. You don't have to worry about that though. It's a name I came up with. So if I go slider, and then I can set the number of sliders. That was a bit excessive, but you get the point. As you can see, I can, if I just move my cursor close enough, yeah, see, I can grab the slider, and then no matter how far away I am from the slider, I'll still be able to act upon it, right? As well, I can also, what's it called? If I'm near close to two sliders, well, how would you expect this to act? So my answer is I basically use something called a signed distance field. Basically, you have a surface of an object, right? And it will give you the distance from that object to your hand, for example. And so all I need to do is take that value of the distance from the hand to every single input handler, right? And input handlers are the sort of the objects that allow you to get input. And then I can sort which input I should try first, right? And I know this is a bit abstract, so I am going to go show you what it looks like in code. I'm going to try and keep this simple. I know that code is not very easy, and also this code is not the cleanest, but I'll do my best, right? Okay, so you can ignore most of this though. The key part to focus on is the input handler. As you can see, the input handler, all I have to do is just define it, and then instantaneously it sends the message to Stardust and it creates the input handler on Stardust, right? So, oops. Once again, a lot of code. But all I have to do is basically say that I don't want the input handler to have a parent, right? So it'll just be floating in space, unaffected and unmovable by anything, except if you move it directly. It corresponds to this field, which basically says, hey, this is a cylinder all around. And then this is just a position and rotation, right? So instantaneously, though, what I can do is I can basically say, hey, this is how I handle hand tracking. Once again, a lot of code, but the basics is it can get the grab strength, check if you're grabbing, and then use another thing I made called XInteract to make sure that you're trying to exclusively grab that object, right? And then if you are grabbing that object, it'll just store that for later until it can actually process what to do with it, right? That's how input works. It is a bit of a roundabout method, but it does allow for basically an unlimited number of objects to exist in the exact same space and all be interactable with rich interactions and not step on each other's toes. As well, it offers you a bit of privacy because not everything has the data of your hand, of your headset, and so on. Only the things that are closest do. So it reduces the amount of data because the number one thing to do with privacy is the less data you can collect, inherently the more private it becomes, right? So yeah. Then I'm going to explain zones. So I hope this isn't too abstract. So basically, the idea behind a zone is like I showed here. Anything inside the zone will move with the zone. And the zone can move objects inside of it. Where was that thing? Oh, right. Let's just spawn in another environment item. And then fire up the UI. Oh, I mean, that's bound to happen in demos. I am working on fixing those issues, and they are fairly like spaced apart. I haven't had them in a while, so let's run the environment item UI, and then the spawner. And there we go, we're back. Right. And then we'll run the workspaces again. So eventually you'll just be able to literally pop open an object, and then you'll be able to grab out an icon that I call an item, right? Drop it into empty space, and it'll expand into the entirety of the workspaces. Where was I? Right. So as you can see, this moves with the object. From this workspace's point of view, all that object is, I'll just go into the cell, right? All this is it has a cylinder field to basically describe the boundaries of where it should interact with objects. And then the zone is the object that can allow it to manipulate other objects in terms of where they are in space. This is even simpler though, right? You just create the field, then create the zone based on the field, right? Then you basically say whenever an object enters the zone, and also if this variable capture is true, meaning if we want to capture it, then we just call capture, and now the object moves with the zone, right? So once again, though, that is how, for example, I can go up like this, and even though this is intersecting with that object, though, it only will capture when I let go, right? So as you can imagine, can be used for all I mentioned, etc. Right. Flat screens, is a bit buggy. And then, of course, when it leaves, it should just remove the spatial from its memory. The nice thing about this is it doesn't know anything about the actual object itself because it doesn't need to. Again, minimal data for maximum privacy. So, what's it called? Yeah. So that's another feature. Okay. Let's go and talk about models. Models are one of the simplest things to create. Just go over to my test project. And this is how easy it is to create a model. Literally 3 lines of code to create a model. You just basically set up Stardust, create the model, and then feed in the file path to a GLTF file, again, using open standards. And then you tell it to stall the main threads so that it doesn't close on itself. And that's it. Do I not have that? Oh, wait, this is the wrong folder. They are a bit big, but they do work, right? And so that is the origin point. Okay, so let's talk about how they actually integrate. I know this is a bit scattered. So with integrations, though, I wanna amaze you all because I have got 2D applications showing up in Stardust, and you're gonna be the first people to see this. So hopefully it goes well. Otherwise, this will be a Steve Jobs moment with the failed tech demo. And so, without further ado, let us try. Let's try this one. And voila. So this is an actual application, a 2D application running in Stardust. This is obviously very preliminary, and actually I integrated the entirety of Wayland into Stardust in a day. It was entirely yesterday I did this. I only did a minor bug fix today, which means that, once again, with the Stardust extensibility, you can, if there is a new feature that has to be added into Stardust itself that can't be made by a client, then it can be done fairly easily, right? And so, this is obviously just to show that applications work and all, right? As you can see, this little piece is transparent. You can see right through it. You can't see the hand through it because of some rendering things, but still. And so what this means is that, that's not all that useful, right? But what if I, for example, show the weather? Boom. I've got the entirety of the weather app running on this. And it's also got a nice little 3D effect. This is literally just a cube with some fancy UV mapping, if you know what that is. So, once again, super duper easy to implement. And actually, I'll show you just how easy to implement this is. This is basically it. So you have the regular setup. You basically say that you want this particular client to be able to have a UI handler. In other words, when you create an item, because technically these Wayland windows are items, right? They're called panels. When you create an item, you need something to actually create the graphics for it. And that basically means that it's a heck of a lot more accessible because you can swap out what creates the graphics and interaction. What's it called? And also, it means it's a lot faster to develop them. So it just says to Stardust, hey, I'd like to create a UI handler. And then if it's going to create, if it's in the create mode, then it'll just simply add a new panel into this list right here. I'm not going to go too much into detail, but basically, this is a grabbable item. It required quite a lot of code to get working, mainly because it's a lot of math. Thing about Stardust is that with great flexibility comes sometimes a bit more math than you hope to do. But I figure that's okay, considering the amazing flexibility and the fact that you can create libraries on top of it so that you can make the math a lot easier, right? Anyway, so whenever the panel is created, it'll just create a new model and a new box field. And it does this based on the height and width, plus the pixels per meter, which is like screen density. If you've ever heard of PPI, it's basically the exact same thing. And then the density, because for example, in this case, this thing actually is rendering at 2 times the scale, which means I get really, really crisp visuals even up this close, right? Which is very important in XR. That's one of the main things that a lot of other compositors struggle with, is just getting the thing to look really nice and crisp. I've also gotten the Simula text shader to work here, which means that even at lower resolutions, Stardust is going to be absurdly crisp. And once again, very performant. So you should be able to run this straight on a mobile headset once those are ready. Right. So yeah, that is how items work. I know I'm talking about a lot of things. My main points here are to say this is what Stardust can currently do, and also this is how easy it is to develop for Stardust, right? And also, this is what Stardust can connect with, because already we've got a weather app right here that actually has a sense of 3D because it actually has thickness to it, right? Actually, I'm going to show you another fun thing, just for fun. Let's go here. Oh. Normally you'd have the panel UI always open, always active, but since I implemented this literally yesterday, it's not quite ready yet. So it gives you this really cool fake window effect. And that's basically for free. So that's yet another example of the insanely amazing things you can do when you take 2D and you basically just bring it into 3D and are able to, with one line of code, map it straight to any object, right? So, yeah. So let's talk about how easy it is to create the 3D models. This is just a Blender project. I literally just created a cylinder and added a material on here. And then I have the top and bottom rings. I can just take this, export it as a GLTF, and then get it using a path. And this is relative to where your actual where your executable is. So yeah. Honestly, I did this a lot faster than I was expecting. Should we go into questions? Because I kind of feel like I need to know exactly what everyone is thinking in order to better answer questions about Stardust. I know it's a bit early. ATPeak people?
Yeah. We're here.
Is it too early to do questions? Because I figure that there will probably be a lot of them.
Yeah, we have some questions. We can go through the questions if it's good for you.
That would be great.
We have a two-part question to start. So Alex, not this Alex though, but another Alex, is asking, Are Stardust OpenXR clients working on IPC like Wayland as different processes? And are apps sandboxed enough to not crush the compositor?
Right. So, first thing, yes, when OpenXR is implemented, because it is not implemented yet. However, I do have plans, and I am preparing the entirety of the architecture to support that. Right. When OpenXR is implemented, the applications will be completely separate. And as for part 2, I can pretty much guarantee that once this is in 1.0 release, that Wayland apps and also OpenXR apps will not crash the compositor. As for Stardust apps or Stardust clients, I can give you approximately a 95% certainty. However, that is due to C++, multi-threading and using seg faults, and so it's just a process to try and iron out all of the bugs. But I'm doing my best. As for why I didn't do Rust, it just doesn't work very well with a lot of the libraries I need to use. Does that answer your question? I guess you can't really give live feedback like that, but
I think it does. There's a follow-up question to that first question. Is the compositor in charge of drawing, or do apps get their own buffer, Z buffer, to compose in? Or does it just supply some drawable instead, like a GLTF mesh?
Right. So like I said before, in the different types of clients, Stardust clients, which are meant to make system UI objects, will tell the Stardust server to draw them. However, all your 2D apps and 3D/XR apps will be done, and they will render themselves. Right. And so, yes, that does include obviously a Z buffer and so on. Hope that answers it. The reason why I actually have Stardust clients be their own separate thing is because I realized that no one team of developers can ever make a system UI for XR that will work for every scenario. I'm sitting at my desk right now. Maybe I want to use a keyboard that's on my desk, right? And maybe I want to have something that has a bunch of little panels that are all of my desktop windows, right? But then say I go onto a plane. Now all of a sudden I'm in a tiny cramped space, and I can't really do much of that though. Plus, I can't really reach out very far. So I need different interactions to accommodate. And so that's why Stardust clients are separate from those two, because that basically allows you to create, here is this object that allows me to interact with my 2D things or with my XR things in this particular scenario. Hope that helps.
Yes. Yes, it does.
Yeah, actually, yes, Alex. The other Alex is saying that makes sense, and yeah, it's yeah, cool. Yeah, it's yeah, I have a questions myself. It's about it's about well, one question is more about what you expect to develop next. I was saying what I know I guess in your mind you have an idea of what's next for Stardust.
I have the whole roadmap. I haven't updated it on the site in a while. I gotta do that. But yeah. What was the question? What I'm going to develop next?
Yeah, correct. What
okay. As you can see, currently 2D apps do technically show up inside of Stardust, but they are not interactable as of yet. So that is the next thing. Like tomorrow, I'm going to work on making sure that Wayland clients are stable, right? And when you hear Wayland, just think any 2D app, right? They can even be Windows apps and even possibly Android apps with the right software installed, right? So hopefully Stardust can literally be the ultimate interface to all of computing. But, we're not there yet. So, yeah, I'm going to enhance this though. I'm going to make sure that you can reliably do it, because I'll show you, in fact, what happens, right? If I, for example, open up the panel UI and then this, it just won't show up. Oh, and it crashed. See, I need to refine it a bit before I just wanted to put out the feature right now so that everybody could see it and sort of get a taste of what's happening. So, yeah. And then after that, though, I'm going to try and work on a bit more examples, and I'm going to make sure that the documentation for Fusion, which is what I'm using here, is a lot better so that people can literally just read the documentation and instantaneously jump in to making Stardust clients. And because they have Wayland support, because all of your favorite 2D apps will work in it, it will also allow you to hopefully make it to where you can just put on a headset with Stardust and you can do all of the development for Stardust inside of Stardust. So, that's like one of my big milestones is being able to take all of my development that I'm doing on this flat screen and do it in XR.
Okay, that's pretty cool, Nova. Yeah, the other question is well, it's more about the development of it. So, where people can find more about Stardust, and then how the community can help you keep developing Stardust.
Yes, absolutely. So you can find Stardust at stardustxr.org, right? As you can see, there's a get started link, which just basically goes into a bunch of different explanations about the more technical parts. And then you can just go straight to installation. And this is obviously manual build instructions. But if you have a Linux distribution based on Arch, then you can literally just use the packages right here. So, and then there's use. So, yeah, I'm obviously going to flesh this out a bit later. If you have any questions, what you can do is you can go to Stardust XR and then just find the links over here in order to be able to contact me or others about the project. Like I say others. Currently, I'm the only one working on it. As for how you can help, I would really love it if people could help me contribute to the core. I oftentimes get pretty stuck on particular problems that happen, or I'm not really sure about architecture decisions, and I kind of freeze up and get paralyzed because this is a very big project and I'm only one individual. I really want a bunch of people to help out on it though and contribute their ideas and such for it. So if you can help me with the core and developing all of the code that makes it to where you can have a bunch of these objects exist in one place, that would be really, really amazing. Another thing is you could obviously spread the word. I mean, the more people that know about it, the more chance there is that people can help, and also it's generally good for a project. But not too fast, obviously. That can cause problems. It is not ready for daily use yet. It is absolutely ready for development. People can certainly develop their stuff on it. But yeah. And then the last thing you could do is if you have something really cool, like for example, you want to create a virtual keyboard or something like that, or something like a DOF or a degrees of freedom interaction, then definitely just contact me or look at the documentation in order to do it. And these are DOFs, by the way. Basically, they're accessible interactions that convert the movement that your body can do into movement that your body can't do, right? So for example, you have something like trackballer, which is literally where you can just take one hand and you can flick it and you can now spin around your controller. I mean, that's something a regular human body can't do, but it makes it practically trivial. So this is the kind of thing you can do in Stardust, right? So just, yeah, to sum up, you can help me develop the core, you can help spread the word, and you can also create things on top of Stardust. All of those would help.
Awesome, really very cool. Yeah, there's extra questions from Ethan, and
yeah, I think It's in reference to your website where Ethan see the stereo kit reference. So he's asking why stereo kit.
Oh yes, that's something I should have I should have talked about more. The stereo kit is amazing though. It is basically the first. It is the first. How do I put it? Insanely performant XR toolkit. So just like how you can develop 2D apps using a bunch of different methods from, React, if you want to be those people, to Qt to GTK, StereoKit is the equivalent in XR. It makes creating any app insanely simple. Like this, give me a second. This is the entirety of how you draw a cube right in the middle. Like that's only a few lines of code, and already you've got an entire application. I chose to use it for Stardust specifically because really short bit of code. It also has something called immediate mode, which means that I can basically create whatever structures I want and whatever architecture I want in terms of how the items and the objects and such are laid out inside of the Stardust XR server. And yet from them, I can basically just draw them wherever I need them to be. That is insanely helpful though. Another thing is it's performance by default, which basically means because I am not in the stage for optimization yet, I can run all of the Wayland apps and such on my laptop with an integrated GPU with a VR headset, 140 FPS easily, right? Which is very impressive considering I haven't done any optimization. So StereoKit is amazing. It was originally developed for the HoloLens, which is very low power in terms of, what it can render. And so, to summarize, it's super duper fast, super duper easy to code for. It overall works really well. And I ported it from Windows and such over to Linux with a lot of help from a lot of different people. Which means that it's basically the #1 way to make XR apps on Linux right now. I've literally already made like another app that's sort of in development, and I'm doing it whenever I'm a bit stressed out with Stardust, which is basically a way to connect all of your audio and video devices together in a nice spatial interface, right?
Cool. Yeah. That's I think you answered the questions. I mean, like we had a presentation with Nick 2 weeks ago. No, last week.
Last week.
Yeah.
Yeah.
So.
Yeah, no, if you haven't seen that, definitely check it out, though. StereoKit is amazing. And if you make anything that isn't an XR game, or hell, maybe even some simple XR games like Cubism, StereoKit is perfect for those, right? With only a few lines of code, you can generate literally any sound with an equation, for example. Like that's the neat stuff that you can do with it, right? I mean, you can read QR codes. Hands are as simple as literally just calling one little function, and now you've got the entirety of the hand. Plus, it also gets all of the latest OpenXR features first, because it's incredibly simple to update. So, really cool overall. And it's cross-platform. It basically works on any platform that supports OpenXR. It'll work on the Quest, HoloLens, though, on Linux and Windows for Steam VR, although not Steam VR on Linux because Valve hasn't updated that in a while, and so on.
Yeah, it's StereoKit is pretty impressive. I mean, like we also use it, so it's like it's pretty. We're really excited. I mean, we look forward also to use Stardust soon to start to play around with it internally. So I think there was actually the other Alex that made questions about the applications and the running apps and so on, and security. Actually saying that it will add a PR for our Pixar USD app support. That is something we are working with them, and I think it could be. You will see. I mean, it's like a like I said, because I'm using StereoKit. If there's any new features added into StereoKit, that basically means that Stardust gets almost all those features. I'll have to implement an interface for it in most cases, but
That basically means, though, that it's a lot more rapid to actually update than a lot of things. The main bottleneck is actually just me being an individual developer working on something with such a huge scale. So, I mean, that's actually a good thing overall, because that means that all of my tools are working like they should. But still, I would very much like help if any of you can provide it. And if you don't know programming or anything, I really need help explaining concepts of Stardust, and I need help with documentation, as every project does. So
yeah, definitely. Documentation is a huge thing in software. I mean, in general. So yeah. So I think we can conclude the presentation. And super cool.
if there's no more questions, sure.
Yeah, I think yeah, that's we were looking at well, there were a few awesome optimizations, were exciting, great demo Nova. There's some, people that were wowed by the simplicity of adding Wayland apps inside Stardust super quick. So there was you can there is a few cool comments about and
I
wow.
hope I explained it all well. If you have any questions, no matter how technical or not, I want to make sure that everybody at least understands what's going on here, considering I was literally updating this talk to the last second. So
Yeah, and we will share your presentation, and also we will link to your website and everything, so everyone can have can interact with you.
Yeah.
I'm gonna do something really hilarious. Basically, I'm gonna run Monado inside of Stardust, though, so you can do wacky things like this already. So I can run XR gears on that, and then panel. So there we go. Look at that. I can run Monado inside of Stardust. I mean, nobody would realistically want to, but you can do it. This is just proof, though, that basically any Linux 2D app will work with it, right? Just right out of the gate. Doesn't have any special features, doesn't have screen sharing, for example, but those are obviously planned features. One of the big things that I prioritized with Stardust is, how do I make sure that every single element inside of Stardust is not only understandable to developers, but users, right? So I hope that, for example, fields are simple enough to where with a few sentences of explanation, or more likely actually just people playing around with them and seeing how they work, right? That it will then, that people will be able to take control over their devices better. Because if they understand how things work intuitively, they don't have to use frontal cortex and all of the really, really difficult parts of the brain. Then that means that they have an intuitive understanding, and they're able to react if something goes wrong, or they'll be able to fix problems when they arise, and so on. I know I'm going on a lot of tangents, but it's kind of hard to make a cohesive thing about Stardust because it does a lot. It has constraints, so you don't have the problem of I have infinite choices, where do I begin? But once again, it has so much flexibility. Actually, I'm just gonna combine all this. Why not? I can literally open up all these things in any order I want. And so yeah. Any other questions?
No, I think there is. I it was pretty wicked. I really like it. It's like there I think Zen. Yeah. Anyway, Zen is saying that when is the next demo? I mean, when I guess you have a few things to develop. I mean, like you said, you're developing, and
I don't generally have a dedicated demo day. If enough people want it, I can certainly do that. Generally, whenever I come up with a new feature, though, that I feel is worthy enough, then I will post it, though. That does happen to be pretty sporadically, though, mainly because, I mean, it's not a case of I can just implement the feature. Because of the way Stardust works, I have to implement the feature, and then I have to make a demo for it, right? So it does take a lot more time to create those demos. That's another reason why it would really help if people actually use Stardust and created things on top of it. Because then not only would I be able to show it off, but also a bunch of people would be able to put their stuff in Stardust. You can't take accessibility objects like DOFs and easily put them inside of an application, right? Because then it only works with one thing, and some things just won't implement it. So Stardust is the perfect location to put DOFs in. I mean, the two people that manage this, what's it called? The two people who manage this, oh, it's gonna be a while to load. Ethan and Nico. I mean, I've been working with them because they need my help and I need their help. And also another thing that works incredibly well inside of Stardust is virtual keyboards. So AJ Campbell's Lexting, which is basically a way to type using 3D and hand tracking, right? Stardust is one of the only options because it's the only thing that applies to every single app. And, you know, yeah. Like here, I'll show you what Lexting. Oh, it doesn't let me go full screen. Not to worry. So this is basically this is what Lexting is. It's where you can have spatial text entry, and I mean 3D spatial, right? This is currently implemented in Unity. However, once again, it would be amazing to be implemented in Stardust. From what I can tell, AJ wants to implement it in Stardust. So yeah, there are a lot of people though that I hope I can help with this, and a lot of people who are helping me. For example, the Monado people helped me make sure that Stardust worked with basically all the headsets that are supported on Linux. The DOF people are helping me come up with a very compelling use case in the early stages of Stardust. StereoKit allows me to create the initial Stardust server incredibly fast and incredibly efficient. And there are a lot of others though. I can't name everyone who's helped me, but I hope I can at least name those people. So yeah. If there are no more questions, I think now would be a good time to exit out of this. I can't really think of anything else to say.
For sure. Thank you very much, Nova. It was a great introduction to Stardust XR. And yeah, thank you again for participating.
If you have any more questions after this, though, just go to Stardust XR and go to the Twitter or the Discord and just ping me whenever. I may not respond, but you can always ping me and I won't be annoyed. Thank you so much, everybody.
Yeah, thank you everyone for tuning in today. And next on the open source ATPeak AR Talk series, we will host Michael Boom from Pluto VR. Michael will present Octo, an open source, cross-platform, cross-device network mesh for composable shared word simulations. The talk will also include a live demo, so I'm sure you'll want to tune in for this. And we would like to thank all of our partners for their support in this first open source AR Talk series. If you would like more info on ATPeak and the lineup for the open source AR Talk series, visit our website, atpeak.io. And don't forget to check the AR Talk series playlist to watch the other talks you might have missed. See you next week.
See you all later. And don't forget, Pluto people are really cool. What's the talk next week?